So, welcome again. Thank you everyone for joining here. As you guys know that we've been doing all our meetups on ground, mostly at Microsoft Center, but this is like the time that we need to do everything online, and here we are. Still, we want to keep the momentum going. So we're gonna keep going until the situation resolved, and throwing online workshop every month, once in every month online. And so for today's topic, we are choosing like level 2 Python stuff. For last 3-4 meetups, we've been doing all the basic Python, and we thought that we may introduce a bit advanced, not too scary, but more like, hey, this is something that Python offers specifically. So let's go and learn about them instead of just doing for while if else, which is like every programming language has those things. And this is something that you can do with the Python. So let's learn much more deeper about all those things, how things work here. I have already given you all the instructions about the intro, all the links that we have for us to communicate in future. And so let's go into topics for this meetup today. So today we will be covering majorly starting with Python functions, where we will be talking about how Python function works and some other tricks and tips, and getting into more detail about Python functions. Then we'll look into something called zip, iter tools, comprehension generators. Comprehension generators are super useful, so something to have an eye on. Map, filter, reduce, which are like more of a functional programming concepts or ideas, and we'll look into them. Parcel functions and decorators, which is like super advanced stuff, but once you are into Python software engineering job, this is something you will do day to day. So it's really good to know about all these things. So let's right dive into it. Please have your Jupyter notebook or Python cell open. We're gonna start with the Python functions. So let's talk about Python functions, starting the basics. So how someone define functions in Python? So you start with something called def. That is the keyword that tell that you are writing the function, and then name of the function, parentheses, and then colon, and then Python is a tab space way to like define the like, so there are curly braces, but Python has a tab way to define the code block. So a tab or for space is the way to like define the code block within something. So here we write all the code that will be within the functions, and you can see the return hello. Return is like whatever you are returning from your function. So here we are just returning the string called hello. Now, few things to learn about the Python in the for the functions. That apart, there are so many languages where where the functions are not first class citizens of the language, but that is not the case here. Python, and like many other functional programming language, Python is not only functional programming language. It do support a lot of functional programming concepts and object-oriented concepts, but like any other functional programming language, Python also supports something called like the functions are also considered as an object, and they are first class citizens. Now, what does we mean by first class citizen? So any language who supports a function as a first class citizen, basically they are saying that our functions are not something special, but it's also some specialized type of object. So now let's see here. What does that mean? So we are running this we define the functions. We are running the functions. It says return. Now let's figure out what is the type of what is the type functions use. So in Python we have something called type. Using type, we can figure out what is the type of certain object that you are passing. And if you see here, it says that the type of myfunc is a function. So it recognizes myfunc as some kind of object of a type function. So basically the idea is functions are also kind of object, and you can do a lot of things with the functions that you would think about you can do with the objects. Now let's see. So one of the thing that so here here the Python object function, like how Python print about any other object and their memory pointer. So within the underscore main, which is like current package dot myfunc is defined here. Now every object has attributes. That's how we say that. It's a car, so like color, make, build, year, produce, all these are objects of a function. All are these attributes of field of an object. So function also has all these attributes that you can see, or field you can see. So how to do that? In the Python, we have something called dir. If you type dir and pass the object, it will try to print all the all the attributes of field that it has. So let's do that. And so if you can see here, my func, which is a function, but also an object, all these are internal attributes that it has, like g greater than equal to underscore underscore doc for the documentation, underscore dict, dir, code, closer, call, annotations, underscore name. So all these things, all these, the size of underscore underscore str, which is like to print, what is the, when you try to print the object, what will you print out of that? So underscore underscore str, underscore underscore init. So all these things are available within the myfunc. And this is possible because here myfunc, although it's a function, but it's also an object, a function style object, and you can print all the attribute of the object. So this is something I want to emphasize in that Python, how Python consider that. So let's go how we execute the function. So normally we say that my underscore func, which is call for underscore underscore call, and you can see the print statement. So just like simple. So if when you say my underscore func without any parentheses, it will print it as a like some object pointer. But when you want to actually make a call, you provide the parentheses and pass any parameters. We don't have any parameters, so we are not passing anything. But so circle brackets will print the value of my func. Now, as I said that it's an object, so you can actually pass around objects, right? You can say x equal to y. So similarly, you can also do the same thing. You have my func, and you can say I'm creating this new object pointer or label called my new func, and I can assign my func to new func. So it can be done, and again you can print that. So basically we've assigned my func to new func, and now your y became x, and you can like x opening closing bracket, and then you can do the hello. So this is the one of the idea that can happen because functions are object here. You can pass around the object, you can give them different name, and then all these are basically pointers. This my func is the label that point to some kind of code block or pointer in the memory, and all you're doing is assigning that memory location to another label, and then that label will just, when you say that the label and opening closing bracket, it will just call for underscore call and print the whole thing. So this is the idea about like why functions are objects, and all these things that you can do with the object, you can also do with the functions in Python. Now let's talk about something else. Now Python, now we see the capability of passing the the passing the Python functions as an object to another label. Now why this is possible? Now there are two concepts, something called first order functions and higher order functions. So when we talk about uh, uh, so Python provide actually higher order functions. What is higher order functions basically? If you can pass your function as a parameter to another functions, or it can return the function as a part of the return statement, that is something called higher order functions. So functions who has capability of passing, either passing function as one function's parameter to another functions, and returning those functions uh, in one of the methods. So this is the capability if language has, then or the function has, then it is called higher order functions. And Python support this capability. So you can literally pass your functions into another functions and return the functions. So let's see how we can do that here. So here you can see that we are defining two functions here, something called mysum, which take two parameter a and b and return a plus b, and then another function called mymul, a comma b as a parameter and returning a multiplied by b. And now let's define a new function called my executor. Now what we're gonna do here, so my executor gonna take first parameter as a function, and then second and third as some other parameters. And what we're going to do is we're going to return the function and then whatever parameter we are doing here. So what this my executor is doing actually, it is telling me that I can execute whatever function you give me with whatever parameter you are passing to me. So in my executor, I can pass whatever function, and then I'm passing two parameters, and my executor will use that function and pass the parameter in that function and execute the whole thing. As you can see here, my func, A, you're passing it A here, you're passing it B, you're passing it B here. So whatever comes here will be executed with A and B by passing the parameters, as you can see in the return statement. So here, what you can do here. So as you can see in the my executor, we are first passing my sum 2,3, and you can execute this and you can see the answer is 5. So in my executor, we pass the label for the function. As Python functions are also object. We are again passing my sum, the function object, and then another two object, which are basically integer object, or integer basic data type object, might not be the exact word for them. And then it will take them and then execute the whole thing and return. And we can try something else also. So same thing. And instead of my sum, let's pass my mul, and then execute the whole thing. So basically it is, so the cell actually print whatever output from the last statement. So you cannot see the output of this, but so this is what is happening here. So as you can see here, within the Python functions has the capabilities where you can pass around the functions and parameters and execute them. So this is all possible because Python functions are higher order functions. So this is where so this is some of the capabilities that you can use when you have multiple functionalities that you can customly define, and then you can choose based on passing the parameter. You can say that, hey, whatever function is being passed here, do a comma b. We'll see more going forward, but the idea here is Python functions are higher order functions, and you can pass functions and parameters around, and you can also return them around. So this is very useful thing. And maybe the initial versions of Java doesn't support that. This is really a functional programming feature. So right now, Java is also coming up with a lot of functional programming capabilities with their Java 8 and 9 and so forth. So they are also now started supporting higher order functions, but otherwise it's not the language that support that, because they don't treat, they have object normal classes as a first class citizen, but functions are not first class citizen in Java. I'm talking about the older versions of Java now, because they are moving towards functional programming. You can see a lot. Now let's see something else. So from the function, you can also extract something called docstring. In Python, when you're defining a function, it's always a best practice. It's always a best practice that you also define, like you can write about kind of something like a docstring to tell that what this function exactly does. In the Python, the normal practice is this three quotes and writing your docstring there. And now if you want to like, if you just want to like print what is the docstring for that particular functions, because of the Python functions, this idea of it's an object, all the docstring that you write under any functions, you can actually extract them, because they're also kind of like stored in some kind of a variable. And here that variable or attribute is called __ doc, this little thing, __ doc __. So as we printed before, all these attributes here in the Python, so one of them is __ doc. And when you let's say when you define the function, and when you write the docstring, that will be assigned to this attribute within the functions. And as any class and object and field of an object, you can also extract that value of their object, and you can print whatever is there. Now when this is useful, sometimes you are, let's say, using some pre-built packages or functions somewhere where you're importing something, import crazy functionality from crazy functional package, something like that, and you want to really see what it does. I mean, of course, you can go online and check and see what it is, but if you really want to read what is going on inside the documentation of actual version package, you can just write, you can just write __ doc for any of the functions, and you can see what it does. So for example, we all know about this pre-built method called sum, and we can really extract what is going on in sum. So this is the docstring that was defined in the standard Python sum method, where this is what it says: return the sum of start value plus iterable of items. So you can, within the sum, you can either define one value or iterable to make all the sum. The idea is if you're using some crazy functions that you're experimenting with, or just want to know what exactly docstring says about the function, you can just say function dot __ doc __, and you can actually retrieve what is going on behind, like what is the docstring that has been written for that particular functions. This can be useful, just something to throw out there. and just backing the idea that functions are also object, and like any object can retrieve the attribute of the object. And here in this case, that attribute is underscore doc to retrieve the doc. Now let's move to the one of those crazy ideas that people often get afraid of. So as we see there, up till now, when you're working the functions, you can say like functions and then a comma b. That means we are providing two variables. But what about the case where you want to support like n number of variables, but you don't know what all those things are? Like I want a functions where I can pass either 3 variables, 4 variables, 5 variables. It's up to me. I can pass any number of variables. Can I do that with functions? Because when you're dealing with the Java or some other functionality, you may have seen that all I can do is my func and then a comma b, and that's it. Like the number of parameters you are setting up hardcore at the point when you define the functions. But in Python, you can define the functions that can take variable number of arguments. And how it is done? So for that, we use something called star args. Those who are coming from the Java background may remember when you define your main method, you do this, like you define, public static void main star args, and that's how you read the command line arguments. So something similar here. You can define a functions, and then within the function, if you want to take variable number of arguments, you can write something called star and args. So remember one thing, args is not like arg doesn't do a set. Like it's not the actual thing that actually make the magic happen. Is this star. After star, you can say args or ar or a or b or whatever. It doesn't matter. When you say star and some kind of label here, that will say that you're going to take a variable number of arguments. So let's do this. Let's see this. So we are defining functions here. We are taking variable number of arguments, and what we are printing here, we are printing all the arguments here. Now, one more thing, when you are using this star and args, so basically what it does, all the variable arguments that are coming through this args will be into a tuple. If you know what tuple is from the Python, Python has a data type called tuple, immutable. Basically just a set of values that you can assign, something like very similar to list. But the idea is when you are working with the args, when you're working with the variable arguments, they will come as a tuple, and you need to treat them as a tuple. So again, we are printing the values, and then we are printing what it coming as a type. So those two things we have defined here in my func. Now let's execute this. So as you can see here, we are writing the three parameters here, passing into my func, and the first thing we are printing is their values, and their values are printed as a tuple. And if you can see, the type is a tuple. So idea is, whenever you are trying to deal with all these args, when you want to extract the values, when you want to unpack the values, this is something called unpacking. Unpacking using star. So this is also another idea into Python called unpacking. You can look up. But the idea is when you're unpacking the args to use them individually, you treat them as a tuple, and then you work with them as a tuple. Use all the functionalities or all the methods that you can use as a tuple data type to deal with them. And so here we are, when you're passing all the arguments, you're passing them as a single integer, single string, and then we are passing them. Can I pass the whole thing as a one list, and will that work? So the idea is when you're passing as a list, here your whole list is considered as a single data object or single data type. So it will not unpack itself, and when you do that, you will get a list as your first parameter. So you can see here again, same thing. So args, so it will take the whole list as your single parameter and as a tuple. And you can see here it's a tuple with a single value, and your first element in your tuple is the list. So this is something to look for. Like when
why does it have the comma and space after it?
This one?
Yeah. What?
So this is the standard way to print a tuple. So for the tuple, when you have single argument, so because this thing 2 plus 3 has some meaning here, because when you say parentheses, you're basically thinking about the expression. So whatever you write inside this kind of comma, it will be evaluated as an expression. So if I write something like this, it will be an expression. So how can I differentiate expression versus tuple? So this is a data structure. This is not an expression. So how can I differentiate that? So for the tuple, this is how we differentiate that if there is only one value, there's the expression. If there's a one, this is like tuple. It's kind of data structure. So it doesn't try to evaluate that and consider as a tuple. So this is the basic idea about comma here. Okay. So Python has so all these things we are seeing as a like you're passing all the argument, you are taking the argument, and this is called positional arguments. So in Python, there are two kind of arguments, something called positional arguments and keyword arguments. Positional arguments are like, as it talks about that, they are positional. Like the first one is pointing to the first, like index is the first and second and third. But what about if you want to pass like x equal to y style? So they are called keyword arguments. We will understand more about what keyword arguments are. And so the difference between when you want to pass keyword arguments are passed like this: n equal to 10 and n2 equal to 20. Like you always pass them in terms of key and value pair, and you can extract key and value pairs. So these are called keyword arguments. And the difference between when you're trying to take the variable number of arguments, when you say star, like single star, and then label them, this is all about positional argument. But when you want keyword, you use double star and then keyword. Same again, keyword has no, like this label KW has no meaning to it. The all magic happens with double star, and using this keyword, you can use your name or whatever, and doesn't make any difference. It will act as it is, like, because this is all the label. The real magic happened with these stars. So let's define my func2 with the variable arguments that only take keywords. Now, one thing to remember, when we are writing here keywords as a variable arguments, we are not defining this single star args. That means this function will not recognize positional argument. If you try to pass positional argument, it will fail. We will see this later, but just to give you a heads up. So because here you are saying that my function will take variable argument, but they will be all of a keyword style. So I can take as many as n1 equal to 10, n2 equal to 30, n2 equal to my name, everything, but I won't take just 10, 20 because that is not defined here. So let's see here. Again, one more thing. So when you pass keyword arguments, they become a dictionary and not tuple, because dictionary is basically mapping key value pair kind of data structure that we have here. So when you pass n1, 10, n2, 20, it will become a dictionary, and this is how it will be presented here. And then you can access whatever label you use for your keyword. The Python default or the best practices, standard practices is to write KW args. So keyword args, we use them, and then you can assume that keyword as a dictionary, and then try to extract the values from the dictionary, either iterating to dictionaries. So now let's put together both things. If you want to have a function that can take n number of positional arguments and n number of keyword arguments, this is how you define them. And see the positioning here. You first taking all the keyword argument, all the positional argument, and then taking all the keyword arguments. And this is how it done. You cannot do inverse way. Positional arguments has to be in, like, you need to maintain certain sequences when you're trying to access them. The benefit of keyword argument is you can assign keyword into any order. It will work because there's a distinguished way for to recognize them as a n1 and 2. So let's do this. So here, if you see here, we are in the my func, we have args and keyword args, and then we are only passing the position argument. None of them are keyword arguments. So you can see the arguments are being tuple and keyword arguments being an empty dictionary. And same thing here. Now we are only passing keyword arguments. So this is the empty tuple, opening, closing parentheses. This is what defines empty tuple. And then you can see the dictionary which has captured the n1 n2 in the dictionaries. And if you pass both of them, this is what you will see here. So this is about passing the two kind of variable arguments, positioning arguments, and keyword arguments, and then you can pass it around and you can access them in terms of tuple or dictionary, and you can use them. They're very simple to use. There are many other permutation combination. We can look deeper into that, but because the workshop is smaller, I can make the whole 1 hour on only keywords and keyword arguments, but I'm just going through something essential for you to know. Uh, okay, so let's move to the next topic. Now, this is something has been coming out a lot. Like a lot of people doesn't uh, get into this error. So what happens? Basically, when you're passing, when you're defining your functions, and when you define some kind of default uh, any kind of default values. So when you say, look at the functions here, def x and y equal to list, and then y dot append x and return y. And what we want to do here is these functions, when we call these functions, this function has to be idiomatic. That means that when I call the function, it has to, like, every time what we want is it will return me y with the list and then appending value x into that list. But let's see what happens here. So I'm calling this function first time. I'm getting 1. I'm calling this function second time. Now, instead of getting 1, I'm getting 1, 1. Understand what is going on here and what we want here. What we want is every time I call the functions, it will initiate y with the empty list, and whatever I pass in a x, it should return me a list with that single element. But when I call the second time, it is retaining the value that was defined the last time. Like, I need my functions, when I pass x equal to something, it has to have an empty list, and it will add that single element into the list and return me that the final list, which only one element. But it is not happening here. Every time I recall the functions, it is retaining the last list that was generated with the y, and then appending the same thing again, even though I'm saying that, hey, I'm calling this function and make my y equal to like create the y with the empty list. Now, this is one of the pitfall that a lot of developers get into, and a lot of people have experienced the bug because of that. So let's understand what is going on here. When you are defining Python functions and when you're defining arguments, you have an options to like give the default values to the argument. So when you want to only pass x, and when you don't pass y, you can define something default for the y. So when y is not passed down, they will take the default value of that y. So this is something that you can do. Like, I can say 3, 4, so 23. So if I don't pass anything for the y, it will take y's default value as 23 and go ahead with the functions. Now, what happens here? When you are defining all these default values, they are executed while defining the functions. So when you define the function, when you create the function object, at the time, this particular pointer, whatever defined here, is assigned certain memory. And this memory will be defined like it's one time. So every time you call that functions, it already has y as a predefined memory location. So it doesn't reassign the memory. When you have a function already, so again, iterating back what I'm saying, you have functions, you're passing these parameters, and you're passing some of the parameters as a default values. Now, when you execute this thing, and when the f becomes alive, when the function f actually create the object, what it will do, all the parameters that you're passing here, it will be executed once, and it will assign the memory location. So what you're doing here is, when you say when you define y, this whatever you're being passed as y has been already defined once. So when I execute this one, f equal to 1, it will take x as it is. I mean, it will take the value of x, and it knows that my y has already been defined that one memory location, which is a list, and that list is a mutable element. So every time I call this function, it will like go back again, use the same memory, because it is not assigning new memory. It assigned memory. It assigned y to the y that memory, the memory pointed to the list, only once when you define the function, and not when every time like you call the functions, because this is just done one time when you create the object f, function object f. So to avoid this problem, always remember that whenever you are defining any argument, don't make any of this argument immutable. Don't define mutable. It has to be immutable. You should not be able to change that value. So what happens when you define this mutable? Because it is only evaluated one time, and it can change the value here, and it will create the problem. So if you're doing y equal to 3, that is okay, because 3 is immutable. You cannot change 3. But when you define list is basically mutable, right? You can do list.append, list.remove, and that can cause the problem, because every time you're calling the functions, it is being referred to something which is only one time defined, which has a global scope, which is not local scope. So this also comes to the idea that you need to define functions which are always idiomatic, idempotent. Idempotent functions are functions whom you call multiple times and it won't change the return value given. If you pass the same argument, it's supposed to return the same values all the time. That is idempotent. So you need to make the function idempotent. So just giving an idea that how functions are objects, and when you define some kind of parameters, default parameters, it gets value assigned. Think about f as some kind of class, and when you say def f, it's an object that you define, then you give them static values, that x equal to something and y equal to this list, and every time you refer to the same object, every time you are referring to same memory locations, and when you say append, it's gonna append. To come out from this pitfall, the basic idea is just make sure that when you pass any argument, any like default argument, they are all non-mutable and either none or something like that. So you can change the same method into this way. Here you are passing y equal to none. None is a singleton special kind of object in Python. Is none. That's what it means. It's a singleton. And so basically when you say if y is none, then y equal to this list array. So what is happening here? This code execute every time when you call the functions. This happens only once, but this happens every time when you call this function. So that is why every time you call the function, the y will be none, because it's always none, and then it will be assigned its own list, and you can get the same value again and again. So let's do this. So you execute 1 time, 2 time, 3 time, it doesn't change. So just reiterating, this piece will be executed, or rather this piece will be executed every time you call the function, but this will be only executed 1 time, because this is what define the functions, and this is what when you call for the functions. So always make sure that when you say y equal to something, this something must be immutable. You should not be able to change that. List is one of those things that can change, so don't pass on list. This is very typical argument. Now let's, so as you can see here, so I found one example, interesting example online. There's a link to the blog post where this problem can occur. So here you can see this is a class. Don't get intimidated if you haven't done object-oriented programming in Python. I'll just simply explain you. So this is a class. This is some kind of constructor, and inside the constructor is also a method. And here you're passing email list as one of the immutable default value here in the list when you create the object, and then you are just assigning those values to its variable basically. So I'll tell you the problem here. So this is the employee where you can add the list, you can print the you can add the email and print the email. What we're doing here, we are creating one object employee1 where we are adding Tony and name as a Tony, year as a 5, and then we are not passing an email list. So by default, it will have email list equal to empty list. And then what we are doing, dot add email, we are adding 2 emails because we want 2 emails for each employee. So self.email list.append. So this is like list.append, and then we are adding the email for the Tony. So, and then finally we have this print email that will print email that has been added. So when you execute this, as you can see here, employee1.print email, you can see Tony and his Hotmail and Gmail account being printed well. So this is something standard. You're creating employee, you're adding emails, you're printing them. It's coming out well. But let's say you are now creating second employee, and for second employee, you're again using the employee and then add email, and then you're printing email. See the problem here? For the second employee, you also got the Tony's list. Why did that happen? Because this one is only created 1 time. And because of that, this email list has been assigned this memory location one time, and because of that, every time when you try to when you try to call this method, it will only gonna look at, and it will only gonna have this memory location, whatever is assigned first, as a default memory location. And because of that, both of the employee objects are pointing the same memory location that has been assigned to the list. So so this is the problem. So this is something, some people call it a bug in a Python language, but so far bug or feature, this is something we need to remember as a when you're using the functions, and just make sure that list doesn't has default. And yeah, of course, the common pattern that you can use always is when you really want to have default as a list, just use this pattern. If y is none, then y equal to list. So this is something which has, it's a standard practice, and you can use that. List is one of the most notorious used default type, and you can use, like you pass email list equal to none, and then if email list equal to none, then you can, like in the body part, you can actually give him default value equal to. So because body time execute every time, it will get the new memory location for each of them.
Can you briefly say something about self and the attributes self.name, self.years? How does it know that self has those? Self is a special type of object, or what?
Yes, self is special type of object, and in the Python objects, and that refer to all the variable that. So it's kind of like global namespace, and then this is local namespace. So using self, you can like point to or look at all the variables and the methods. This is something we can talk more about if we ever go to object-oriented class, and I can talk. Okay, so this is something I want to discuss about the arguments, how the arguments works and things like that. Okay, going forward, let's talk about something called Lambda or inline functions. Lambda is again a very useful thing that people can use. What it does, what is Lambda? Lambda is basically anonymous function where you don't define functions, and so you create the function without name basically. There's no big difference, but first thing, you create the function without name. Second thing, they are short enough to be inline. So you're not writing like an anonymous function with 10 or 30 lines. It has to be only one line, and this is something very handy when you are using when you have a function that is asking for other functions. We will see it in the example later here. So let's look at this now. What I'm doing in the line 1 is absolutely you should not do, but I'm doing this so that we can better understand how Lambda things work and how it used. Again, I'm reiterating, I am defining the Lambda function here, and then I'm assigning Lambda function to some kind of variable. You should not do that in your regular practice. I'm doing this to like understand more and explain more how Lambda works. So just heads up that don't do that. We will see how to use Lambda like right away, but don't like give the name. Rather, you just do def my inline versus doing this Lambda thing. So again, let's come back to Lambda. So Lambda is so first piece is like, of course, the keyword Lambda that says that you are defining the Lambda function. Then there are two parts. This is like input parameters, and then there are return parameters or return statement. Here x and y, so we are in this Lambda function, we are passing two arguments. You can pass any number of arguments. So here we are choose to do the two arguments, and then what we are returning is x plus y, sum of those two. And this is our Lambda functions, a very simple one, two arguments and return statement here, single return statement. So we don't write return, but that's the thing, like whatever you want to, whatever expression that you want to being evaluated and return, you just write the expressions and the result will be returned here. And so this Lambda function we are storing in my inline. You can do that because, as I told you, Lambda function is also function, just a special kind of functions. It also has all these like being an object and stuff like that. That is also applied to Lambda functions because they're also kind of functions basically. So they are also function objects. So when you say type my inline, it says function, very similar to when we were using the def. Now let's just see what my def says. So above, when we are seeing that main dot then there were like function name and opening closing bracket when we are looking up online here. So here when we where was it here when we say when we are trying to print, it says my func and then print, and here when you try to print, it says in main your current module package and then lambda and x comma y to tell that this is what it is. I'm doing this to tell you that lambdas are also like a function, and they're also inherit all the object properties, because functions are also object. So lambda functions are also object in a way. Now you can do something like this also, because now my inline basically refer to, or it's kind of a label for this lambda that you have defined here. So you can pass the argument like this. Again, if you really want to do something like this, you better just do the def and whole classical functions thing. But just to tell that you can also do that, I'm presenting that. Otherwise, this is not the use case. Again, to tell that you can also use 3 variables, 3 parameters. I mean, you can use n number of parameters and return can be anything. Here we are defining lambda functions, which can take x, y, z, 3 parameters. And then on the return, look at this. This is a tuple. First argument of the tuple is x plus y, and second argument is z. So when we do this, 1 and 2 will be like added and return 3, and the third one just return as it is. So a bit about lambda functions, like this is what normal lambda functions is. So again, reiterating the same thing, because I'm using anti-pattern, I should not do that here, but just to like make sure you guys understand, the lambda is also kind of functions, but always never like assign the name to lambda function and use them like this. This is anti-pattern. So let's see what kind of use case lambda function has. We will see more use case going forward, but let's look at this particular one here. So sorted is one of those by default methods that come with the Python function, which can sort your list or any iterable. The first thing we are passing here is the iterable range -5 to 6, which will basically create the list starting from -5 to 6. And sorted has something called key. Key is like, so with the key is expecting some kind of functions that function or expression that it will use to sort your list. So basically, hey, I have this element -5 to 6, how I want to sort that. And you can give some kind of, your custom logic to sort them. And how it does, every element that your list has, you pass into these functions, and then you kind of like create the second index kind of thing and use that index to sort them. So let's see the output here and understand that. So -5 to 6 will give you number from -5 to 6, -5, -4, -3, -2, -1. And what key or what our lambda function does here. So key is basically, so there will be like an internal index kind of thing that will be generated to sort all these numbers. And when I say key lambda x squared, so -5 will be assigned to x, and it will say 25, 24, 23, 22, 21. So basically you are squaring all of them. So basically each number in this list will have some kind of associated key, internal key that will be square of its own value, and it will use that squared value x squared to sort the whole list. And because there is like negative numbers, and when you square them, all the negative will get positive. You get this kind of like output, like 0, -1, because these lambda functions which take x and return x squared will take each value from this range, put it back here, make the square, and give the key as output. So there will be like separate kind of list generated, very parallel to this, and then based on that list you actually sort them. And here you can see 0, -1. Now you can also do the same thing. So there is another method, ABS, like absolute value. You can use that too. So here, just to showcase the use case that how lambda is used, like something where you just want to like pass something very neat. You don't want to create the whole method here. Like you don't want to define def square and then go through all those kind of overhead of defining method and doing all this thing. If you want to define something, some small sweet method, you can just use lambda function, just pass at the same time and just get done with that. You don't name them, you don't tell what it does. It's just super small sweet function that you want to pass sometimes, and that is the use case of Lambda function. That is how you should use them. There is another one method here. It's so again we are using something called filter. And what I will tell you, I won't go in detail, but what I will tell you is in the filter, it will take function as a way to give me the function that will tell me yes or no to to pick the element from the list. So my list has integers and strings, and what I'm telling is if a particular element is an integer, then keep it. So this is like small function which all it does is take the element and tell that whether the element is the type of an integer or not, which is basically just like type X. You pass the object equal to integer. If it's the type of integer, then it will say yes or no. So this is kind of like use case, very small, sweet. You don't want to like go define big function, everything very lightweight, single line, short and sweet to get done with this. So this is the use case of Lambda, and this is what you should use for. So now moving ahead, we are getting into this landscape of iterable. How much time we have? Oh, okay. We are already, okay, we'll see how far we can go here. We are already 7:20, which is like, oh God, I didn't expect it. Anyways. Okay, so zip, what zip exactly does? Zip is a function which take multiple iterables and kind of like bind them and give you another iterable where you can iterate over all of them. So let's say we are having 3 iterables here. Iterable is anything that you can iterate over. So my list equal to 1, 2, 3 list, you can iterate over list. We have tuple, you can iterate over tuple, and then you also have a string. String you can also iterate, and it's a iterable, and each time you iterate over list, iterate over string, it will give you a character. So what you can do with the zip, you can say zip and pass all 3 iterables. It can be anything. It can be list, it can be tuple, it can be string, it can be multiple of them. I can also say my list 2 times, and what it will do is it will get a zip object. Now again, zip is an iterable, so all the iterables doesn't return the result. What it will do, it will give you some kind of generator or some kind of iterable. And iterable, what it does, it doesn't iterate right away. You need to ask for next value. So if I want to know what is, if I need next element from the iterable, so it will evaluate the first element and give me the first element. So first element is 1, 1, and m. This is the first element in this iterable when I'm zipping 3 iterable into tuple. And again, when you zip them, they will return every element from every iterable in the single tuple. So go next. Oh, I think so it's kind of redefined all the time. So list will not work. I need to like say my zip, something like this to get new element. Okay. So, and if you don't want to like iterate like one by one, what you can do, you can just say list, which will enforce it to iterate over till the end, till it exits. And if you can see here, so you can see here, my list has only 3 element, my tuple has 4 element, and my zip has 6 element, 1, 2, 3, 4, 5, 6. But list zip will only go as far as your list element, I mean, minimum length of the iterable. So your first iterable has only 3 element, so it will only iterate till 3 element and won't go further. If you want to go further, you want to have more elements, there is something else that is coming up next. We will present that, but by default, it will go as zip will go as far as your minimum number of elements in any iterable that you have. Now, some of those useful examples that, let's say you have a string and you want to assign, you want to some way like, you know, give the number to them. So this can be some easy way to do that. What we are doing here, we are zipping a range, which is an iterable. Range will give you 0 to 10,000 numbers. I'm just saying 10,000 because I don't know what my string size is. And as I told you, like zip will only go as far as the length of my screen, length of whoever is the minimum. And I'm anticipating that my string will not go more than 10,000. So I'm just saying that, hey, let's go to 10,000. What I'm doing here is I'm zipping this to iterable. And when I say next, so I get m with the 0. When I do next time, 1 with the y, and then I can keep on going, and it will keep on going until it reaches to something called stop iterator. So this is how iterator works. Iterator will keep on iterating until it reaches to something called stop iterator. And when you're defining iterable by yourself, when you're like writing your own iterable, you will use something like this to tell the next or any other internal methods that, hey, you need to stop here. I'm done with my elements. So this is how you use iterable. By the way, next is a keyword which will internally invoke either next method or underscore next method, depending on Python 2 or 3, and then it will call for the next element. Okay, so when we're talking about, so now let's go to something called iterable tools. Iterable tools is a package or set of functions that you can use, which you can use to create the iterator and efficient looping. So what is about iterator and efficient looping? So as you saw here, we were picking up element one by one. We were not saying that, hey, give me all the elements at the same time. It creates the elements every time you ask for the next one. It doesn't create 1 lakhs element when you ask for give me 1 lakhs. You one by one ask for them, and one by one it give it to you. So in that way, you can efficiently process the data if you have huge amount of data, and that's why lazy evaluate iterables are important. Now, Iterable Tools is a very useful package where you can find very interesting, iterables that you can create out of your list or methods or something like that and use them one by one. So one of the questions that we had here is like, as far as I'm going here for the minimum, can I go for the maximum? Can I go for like, can I create the list or iterable that will cover all the elements, like go to the maximum elements? You can use something called zip longest in the iterable tools. So here again, those same my list, my table, and my str. And okay, sorry. So let's first do the import, and then let's do this. So it will give you the iterable. As I told you, because it will give you iterable, and it will not give you the list itself. You need to use list to kind of like evaluate the whole iterable until it reaches to the stop. So what list will do, it will kind of like iterate over the whole thing, and when it reaches stop iterable, it will stop iterating. So here we can see here, so 1, 2, 3, and then when we ran out of 1, 2, 3, I mean, we ran out of elements from my list, it will just appending none, and it will go till your my string, which was like last element. So everything that doesn't catch up, it will just add the none to them. So you can use something called zip longest if you want to go as far as your longest iterable. And there is an options where, so here it is by default put the none, but let's say I want to put something custom. So let's say I want to put up NA. So there's an extra parameter comes with zip longest where you can provide called fill values. And again, same thing to see them, let's use list. I can also do the next, but first, before using next, I need to assign them. So it point to same object. So here you can see that fill NA is all filled with the NAs. So there is one more functionality here, basically, to like, if you want to do something else instead of none for your other methods. Now, one more a method from iterate tools which I want to talk about, or I want to showcase about, is called take a while. So let's say you have an iterable which has list of elements, and then what you want to do is you only want to take values from this iterable until some kind of condition is met. And again, same here, you can pass the lambda here. So this is another use case for lambda. So what I'm doing here, that iterate.takeWhile will return me an generator or iterable which will take the list and only return me until this condition is true. At the point where the condition is false, it will stop giving me value from this list. So 14646, what I'm saying here is lambda x, where x is less than 5. So this function will be true. It will give true for the x until x is less than 5. So when I do this, I will go 1 and 4. So as soon as I reach the 6, condition will be false, and it won't go further. It will only give values until 1 and 4. Again, I'm using list to evaluate till the end. You can still keep doing next to extract the new elements. Now another big topic. I will try to go as fast as possible. We might go for like next 10, 15, I don't know how many times, how long we can take, but we'll see how far we go. Okay, so next is the comprehensions. Comprehensions are kind of a way to generate the list. These are very useful and sometimes can be If you are not using the iterable, you can use this to create the list, which is something useful. What it looks like. So comprehensions is basically you can create the list and dictionaries using comprehensions, and how it works. So this is the example where you have an existing iterable or list or any kind of iterable, and you want to use that to create another list or another iterable. So in the list, how it works. So what you do, you say that for variable in some kind of iterable, and then so from this iterable, each value coming out of this iterable will be passed on to this x, and then after this x will be taken here at this point, and then whatever execution or whatever expression that you write here will be the final result or answer or element that will be added to the list. So if we do for x in range 10, so what you're doing here, from range 10 we are taking element 0, 1, 2, 3, 4 up to the 9, passing it to x, and then what you're doing here, we are just saying that 2 raised to that x. So this is the answer. So basically for each x that is being passed on to here, we are evaluating that x to 2 raised to x, and this is the answer that we get here, basically 2 raised to power. So let's look at the common pattern here, how things happen here. So for variable, so first is go to iterable, it take the element from the iterable, it bring that iterable to the variable, and then finally go to the expressions. Now there is this third step here called condition. Let's look at what is this condition means. Let's say you are running this iterable, but you don't want to pick each and every x and then put them into the final answer. You want to do some kind of conditioning on x and decide whether you want to take this x to your final list or not. So what you can do, you can write if and then some kind of expressions here which will evaluate to true or false. So for x in range 20, so what it will do, it will take element to x and then take whatever variable or x to this place and try to evaluate this expression here after if. And if this expression says true, then it will come back to this part and finally do whatever you have defined here and finally give an answer. So what we're doing here, we are taking numbers from 0, 1, 2, 3 up till 19. X will become here, and here you're checking if x module 2 equal to 1. So basically you are saying that whether this object is odd or not. And if it's odd, then keep the x. So if you see here, you can see like 1, 3, 5, 7, where you are picking all the, because for all, when there's a 2, x equal to 2, 2 module 2 equal to 0, that is false, and like it will never come forward. So again, going back here, for iterable, take the element which will be assigned to this variable. This variable, either you can take this variable here, or you can have some kind of condition here. And if condition is true, then you go back here, and then if this is true, then only you go back here and then do something with the x. Otherwise, you just skip the x. If this is false, then take the next element and start again with the conditioning checking. More like a for loop, if like, where you check the condition middle before you go forward. Anyways, so this is how you do the comprehension for the list, and same for the dictionaries. You can create the dictionaries for x, and here, because dictionary has this key value pair thing, so here is your key and here is your value. You can take an x and create any kind of custom key and value here using your x. Here we are doing key as it is, key as a same variable, and value as a the power to same thing, so squares. And same here for the odd squares. So same thing that we did before. We can not only iterate over things, we can also put some condition to decide whether you want to go ahead with this variable and actually go and execute them here or not. So here you can see that we are only picking the odd squares. Give me some more time. I think we will go through generators, and then we'll see if we can go further, because generator will also take time. So what are generators? Generators are basically the way to generate new elements, or you can that will give you the next element. And why you want to use generator? Because when you use generator, you're not creating all the elements at the same time, and you are only asking element one after one, which make it memory efficient. Because if down the road I don't need all the element to execute at the same time, I can just pass on one by one element, process them, and return them. I don't need to go for all of them. So how I can define a generator? So as you have seen, we went through a lot of generators, and there are two basic ways to define the generators. Something called class-based, and then something else which called function based. When you say you have a list, or when you have some other classes on which you can ask for the next element, how it is being done. We are getting into object oriented a bit here, because this is a class based or object based iterable. So just bear with me. So here, when you are like, say, creating some kind of you want to create a generator over some kind of custom object, let's say a person or something, uh, you need to define these two methods, underscore iterator or underscore next. And this is for Python 2. Python 3 will have this next here, but uh, this is something classic, this two one. And then you can also do the next one. So next is basically to fetch the next iterator from using your class. And so here, what we're trying to do here, so we have this first n method. We are creating the class which says that we're going to fetch top n methods. So this is the iterator. And when we define iterator, we want to say that how many numbers you want to iterate through this iterator. So we are defining something called n, which will say that, hey, give me an iterator which can give me the element up to 5,000. And then every time I call for next, it will give me one more number. So this is something you define here. And then self.none for our tracking when we are, so iterable are one side way. So let's say you define the iterable which can give you 100 elements. So you can only go like 1, 2, 3, 4. You cannot go backwards. You always go frontwards. Now, I'm not saying that this is the language barrier, but this is more of a standard practice. And if you try to like create a iterable and try to customly write the previous logic, it will be hell of a weird thing. So don't do that. Always when you try iterable, don't think about going backward. It will always go forwards. And if you define your own custom iterable, always try to define next one. Don't try to design something that go backwards. It will be hell. Just putting it out there. So now def next. So here where the actual magic happens, because every time you define iterable and then you want to ask for next variable or next object that you want for them. Now, how iterable give you the value and how it stops. So basically, every time you say next, your iterable will basically return, wherever it is, whatever the current it is holding, and it will go up till something you call something that we looked at before, until it encounter this stop iteration. It raise this this exception of stop iteration. Until you raise stop iteration, it will keep on giving you next values. And so the thing is, lot of these inbuilt methods or functions who is let's say list or sum, who is taking iterables, when they are asking for, like when you're trying to fetch all the values from the iterable, it will go until it reaches the stop iteration. So if you don't define stop iteration, things can go other ways. So whenever you're defining something, always when you're saying that, hey, this is where my iterable stops, this is the last value of my iterable, always for that condition raise stop iteration, so it can be compatible with all the other methods. So let's define this class here, and then let's go into sum. So as you can see here, sum will go for all these elements, and one by one, it will use this iterable to fetch the new element and add them. And let's look at some more in detail, because sum will like go and like try to go as far as possible, and as far as possible is up till this 1000k. And this, after this, it reaches this 1000k, it will hit this stop iteration raise, and then it will stop and it will sum up all the elements here. Let's see this in more like close manner. So we are again defining our iterable by passing n equal to 5. So our iterable can go up to 5 numbers. That is what we want to do with this one. And when you say that 5, your n is set with the 5. So this is our endpoint. And now when you say next of fun n, so what it will go? It will say that self dot. So your n is here is 5, and then you have something called self dot none, which tell that what is your current position that you are trying to extract, because iterable, once you define, you can always go one forward. So you want to track at what step you are. So we are using self dot none to put the step, and you keep on going until your num is less than n. So basically until you haven't reached the value 5. And if you reach the value 5, then you raise the stop iteration. So I'm gonna keep doing next, 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 next. Now it will reach the stop iteration. Now, because I'm using custom next, it will raise the iteration, but let's say if I do list, it will give me fine. So again, I have to redefine because as I told you, when I executed list, there was no element left. I was already ran out of all the elements. So going back again, saying 5, so list will give you 1, 2, 3, 4, 5. Now let's taste this idea of the raise will actually stop the whole thing. So I'm defining this custom thing, some small bug here, which says that if number equal to 3, just raise the stop. So when I do this again, when I'm defining this whole thing again and do this again, sorry, I need to redefine, re-execute the whole thing. So my new code will be part of this and this and this, and it will stop at 0, 1, 2. It won't go till the end because as soon as it hit the 3, my list will stop because it has hit the stop iteration. So this is how iteration go to up to next point and return back. Now this is for the class based. Now let's come to the function based. Now the magic happens here with this statement called yield. Yield is the keyword that you use when you use with any functions. It will not return the value, but it will create some kind of iterator. So every time you call this method, it will not say that, hey, end this thing. Like it will keep on going. And I mean, it will become an iterable. It will not be a typical function with return the list. It will become iterable and will return you the next element every time you ask for one. So what we are doing here, we are defining function f, the same thing that we want to do here, num equal to 0. And this is the condition for which we want to keep on adding the number. We want to go until this condition is met. So that is like the number of iterable. So if we do this, this is the same functionality that we did before. A lot of people prefer to use functions for creating generators, and that is what people use because it's short and sweet versus going for all the class-based thing. But it's up to you, like, or just for the, if you're using some kind of class and it has iterables to understand how it works, I threw that thing upstairs. But if you want to do something, you're probably gonna define your own functions with the yield keyword. So what happens here, when you say yield and some number or whatever value, every time you say next, it will return whatever, it will kind of like pause there and give you the value that is being written by the yield. So I define the function here. So let's see the example here. I'm defining my function funf with 3. So I want iterable that can give me up to 3 numbers. And when I call for the next one, what it will do, it will go here, it will check the condition, it will say yield num. So right now my num is 0 and my n is 3, which is like it's gonna stay 3. And when I say yield num, so at this point the value of num is 3, so it will return me 3. And at this point my position is like paused right now. So the value of num will be saved. So when I say num equal to num plus 1, so this state will be saved. Why this state will be saved? I'm working on the same object. It's a function, but it's still an object. This is an instance of an object, kind of like, you can say that it's kind of an instant. And then when you say next of func, so basically you are working on the same instant that you define here. So because of that, when you call next on a same instant or same method, it kind of like, so again, when you say next, it resume this thing. Again, num will be evaluated. Num will be like now 0 to 1 and then come to yield and it will return the yield. So at the point of yield, whatever is written here, it will return every time you say next. And then you can keep on going. And because of the, so this is something because of the yield, stop iterator is inbuiltly defined. So when you say next and you can't find something, it will just say, oh, I can't find it. And if you do list here, again, I need to, because iterable has run out of, I need to like redefine the iterable because my old one has run out of all the elements. So, oh, sorry. It will return me 0, 1, 2, 3. So this is how you use yield to define your generator in the functions. And we were looking at the list before. So here you can see here generator expressions. By default, we have seen this method to create the list comprehensions. But if instead of those square brackets, if you use the round brackets, it will turn into a generator instead of list. So this is something like you can convert comprehensions to generator expression. There's a special keyword for this. This is called generator expressions. These are all called generator. This is called generator expressions because you have an expressions, and which is you use comprehensions. Everything that is same apply to comprehensions also apply here. The only difference is when you, instead of a square bracket, you say curly bracket, it becomes a generator expressions, and then you can ask for So here I said list, but you can do the next of all, and you can ask for element one by one, one by one, one by one. You can, as you can see here, it's a generator object. So this is how you can deal with the generators. So we see three methods: class-based, function-based, and expression-based. Now I see that I'm really ran out of time. We have still more content to go. Now, if you guys can quickly tell me if you can. So I can see 16 people. And if you guys say you want to stay, just quickly type yes and no so I can know that
Yes.
go forward. Or,
I can
okay.
stay.
Okay. Okay, seeing a lot of yes. I think I have my motivation to go forward then. Okay, cool. Now next, move to the map. Map is coming out of functional programming paradigm. We can say that. What map does? What it does is, let's say you have a list or iterable, and you want to apply certain functions on that iterable. So you have an iterable which has like different values. So this is iterable. It's a list. It has different values, and you want to apply certain functions or certain like method on each of the element of the iterable. You can use something called map. So how it works? So let's start with defining one functions. We say there's a function called upper, which will take a string as an input and convert into upper. And then when you apply map, what it does, map is also kind of like a generator. So you need to use list to see the result. But what it will do is this is the function. Here you write your function, and here you write your iterable, and it will apply this function to each of this iterable, and finally generate the result generate the result out of this. So like this. So what is happening here? On each iterable, this method will be applied on each element of the iterable, and whatever answer comes out of that particular element will be your result. So sentence will be passed into this upper method, and whatever result come out of this method will be put into your answer. Fragment will be like taken out, put into the upper, and which will be like again executed, and output will be put back into the list. So this is how map works. So as you can see here, inside the map, the number of elements that get in and number of elements that comes out are the same. So that is one thing to remember with the map, that every element that goes into iterator, when it comes back, it will be like same. It's just a transformation, mapping from X to Y basically. And this is your mapping function that you apply here. Map can take minimum one iterable. You can pass multiple iterable, and then it will again work as same. Let's say okay, sorry. So this logic is like when you have functions which can take, let's say you want to take two lists and two elements. So if you want to say, let's say do the concatenate, you can say, I'm not going to execute this, but I'll just save how what you can do when you apply multiple iterable. That is basically passing multiple parameters to your functions. So let's say you have functions which take multiple elements, multiple parameters, and you want to like have multiple, let's say list one, list two, and you want to say that list one's first element, list two's first element will go into my method a comma b, and then answer will be stored into result. So this is something you can do with multiple iterables. So when you apply multiple iterable, the element will be picked up in sequence from each of these iterable and pass into the function until you get the result. So that is something you can do with the map. Now filter is something slightly different. Filter also take a method and then an iterable, and what it does is I have shown the example before that it take each element, apply this method, and if method says yes and no, true or false, or like true is or false is, if it is something that says true, then the element will be kept, and if the method says false, it will not kept. So here what we are doing here, we are defining a method called is even, which says that, hey, this is the even method, like whatever, if x is, I will tell you whether the x is even or not by checking, by moduling and the logic with that. So from the range, when you say 0, 1, 2, 3, 4, each of this element will be passed to is even, and then evaluated, and if answer is true, then it will be kept, and if it is not, then it will be thrown out. So again, here you can also pass lambda. I passed is even, but you can just say like, lambda x x modulo 2 equal to 0, and then it will also work. I think we have the similar example that we did here, not here, slightly here, where I pass lambda. So you can pass lambda or you can pass method. It will act the same way for the filtering. So this is the filter. Now, reduce is something different. I choose reduce because a lot of people who are coming, so map and reduce go hands in hand if you are working in the data space and if you know the Hadoop. And so reduce also kind of like interests me because it is also very interesting functionality. What you do with the reduce is you have an iterable and you want to reduce that to some kind of answer by applying some kind of operator. So let's say I have a list of 1, 2, 3, 4, 5, 6, let's say n number of elements. I want to add all of them. So I can apply some method which will like reduce all this list, all this iterable into the single value. So when you have an iterable that has multiple elements and you want to reduce them to single value by repeatedly applying some kind of operator, that will be like my element 1 operator, element 2, whatever answer comes out, that answer will be that answer, and my third element will be operated. Then answer of my like that result will be on the fourth element. So like, so this is how reduce work. So let's see the example. Is again coming from the func tool. Your map and filter was like inbuilt. You don't need that, but like longer zip and reduce, it will come from the func tool. So let's say we have this element A, B, C. What I want to do is I want to concat them. So when I say func tool reduce, what will it take? It will take the A and apply this concat. So A with single element, when you apply concat, it is just A. And then when you say B, so what will it do? It will take the result of previous operation, which was A, and then apply the B with the same on the previous result, apply this operator and generate the result. So A, previous is, my previous result, concat BB. So A, BB will be the answer because I'm applying the operator onto my previous result. Now I have operated 2 elements and my intermediate result is ABB. Now this result, concat and C, and that will give me the ABC. So this is how the reduce works. This is useful when, let's say you have n elements and you want to define some kind of operation over list of elements, but try to write the function which says sum and which can also handle the single element. You can do sum easily, like if your list, pick the first element, pick the second element. But what will we do if you have only one element? You have to like, if I have only one element, just return the one element. If I have more than one element, then I have to like keep on going and adding. So it kind of like, the idea is when you want to like reduce a list to a single element, it kind of like very messy logic growing up. But if you want to do something very neat, one line clean, you can use reduce to like, hey, this is the elements, and apply this method on like consecutively on the like, take one element, apply the method, get the result, apply the second method, get the result, and keep doing that until I reduce the whole list into the single thing. So this something becomes very helpful. People who are working in data may find this useful. And everything that we have been doing here, so what we are doing here with the map, you can also achieve the same result using generator or using the list comprehension. Same for the filter. You can also do like conditional comprehensions and achieve the same result. These are multiple ways to do things. This is more functional programming way to do things. And previously what we saw was more like a, Pythonic way of doing things, not so functional, I would say. So yeah. Okay, so I still have 13 people, so I'll still keep going. Let's look at the parcel functions. Now, parcel functions you see around a lot, and you may get like, hey, what is this thing? Like, it just sounds weird or intimidating. Basically, parcel functions is like you have a function which take multiple arguments, but using that function, you want to create another functions, and that another function will have certain values as a default values. Then you can create something called parcel functions. Parcel functions are like basically the version of your original functions, but certain value has been already set as a default. So let's look at them. How we can do the parcel function. So let's say I have a function called multiply, which takes two variables x, y, and then multiply x into y. So if I want to
create the parcel functions, which takes like which is like double the number or triple the number, which is basically a specialized version of multiply, where I fix a one parameter which 2. When you say double, you can say call the multiply by whatever number I'm passing and just pass 2 as a static number. So this is one way to create the parcel functions, where you're creating a specialized version of your general function, and you're kind of like rigidly setting certain parameters or certain arguments. So now instead of taking instead of passing like multiple parameters, you can just pass single parameters for that special use case. This is very useful when you want to reduce the number of arguments that you pass into certain functions. Let's say you have super generic functions, which has like, let's say, tens of arguments. And now you're using that function into some special context somewhere where, let's say, out of those 10, only 5s are going to change. Other 3 going to always stay fixed. So you can take that variable and then, reduce the parameter by creating the another parcel functions where you set those other 5 as a fixed values and only like recreate them to like repass the values from this other alternative variable. Now, as you can see here, if you call for double num, you just pass single variable and it will internally call multiply, and it will. So this is basically how you define parcel functions basically. Sorry, this is your parcel functions. Now, so what is about this parcel keywords? So same thing, if you don't want to do like, I don't want to like, write my own functions and do all this thing. I want something much more neat and much more super easy or like simple. You can use parcel keywords. So how parcel keyword works? So with the parcel keywords, so parcel, and then you pass the functions, and then you have this arguments and keyword arguments. So this is the, like you first pass what function you want to, let's say, create parcel functions out of, and then you pass the keywords that you want to set as a values. Now, here I have multiply functions, and that is my function, and I'm passing 2 here. So what happens? Whenever after function, whatever keyword I pass here, whatever argument I pass here, that will be set as a default for your multiply function. So when I say parcel multiply 2, so this 2 will be assigned to x, and now my multiply by reduce will def 2, y. So basically, every argument that I assign here will be one by one assigned to each and every passing parameter here, and then it creates your specialized function. So here there are only 2 parameters. So I'm setting 1 parameter. So that's why when the default num is created using parcel, because x is already set by 2, double num can only take 1 parameter now, because that is only the variable parameter left at this point, because we have already set the value of x here. Let's say this has like, let's say 5 parameters. And if I say 2 here, now def num will take only 3 parameters because 2 will be set by here. So this is how you create the parcel functions. It's a super easy thing. It sounds weird, like parcel functions, like crazy thing, but it's actually super simple. It just, you're creating specialized version where we are setting the, some of these parameters as a static values, and create the function which only deal with the remaining of the variable values. So this is all about parcel functions. Good to see that we still have 13 people. So we will go for our last topic, decorators. Now, decorators is again one other intimidating thing that people have seen before. So what basically decorators are? Let's say you have some function or some decor is a very common pattern, but let's say we only talk about it in the context of Python functions. So what happens when you do the Python decorators? When you apply any kind of, when you have method for which you want to extend this functionality, you want to add something more to existing method. So you can use decorator to apply or extend the functionality of your method. And let's see how it works. I think example will make things much more forward than saying out of words. So let's say you have, we have a function called func. Okay, where is func? So this is how normally you define the decorator. Decorator is also a special kind of functions which will take function as an argument. It has one wrapper method. It returns the wrapper method, and you can call this. You can like add extra functionality around these functions, and then write the things. So let's start with the function. I'm defining here a small function called call my func, and this call my func, only thing it does is it prints I'm called. Now what I want to do is I want to wrap this method or add extra functionality where every time I call these functions, I want to say that this function is being called and this is this like execution is started, execution ended. I want to add extra functionality in this call me func where this function will tell me every time it is being executed, like starting executing and ending executing. How I can do that? What I can do is I can define something kind of decorator, and within this decorator, what it will do, it will kind of like do check in, check out for the functions. So in my decorator, I will pass the function, whatever function I want to pass. And in the def wrapper, I'm going to like call these functions. And before I call the function, I'm going to say that print this one, print check in and print checkout. So print check in, call the function and print checkout, and create this kind of wrapper and return the wrapper. So as you can observe here, first thing, this is function agnostic. So when you create the decorator, it doesn't have to be specific to single function. It is generic. You can pass any functions and it will call this function between these two print line. And so how do I apply this decorator into my call functions? So what we have to do, you have to kind of like redefine the function. What we are doing here, so for this my func call, we pass this my func into call func through this decorator. So within this my decorator, we are passing these functions without parameter, just name of the function, because as we are passing this kind of label, kind of object, we are passing the function object to this another function as an argument. And once my decorator will take this function, it will like modify this function, and now the modify functions. So if you see here, my decorator is returning another function. So this is another function which is being returned, and your original function will be overwritten by this new function, and this new function kind of wrap around your original functions. So your original function is now being called in between these two methods, and this is a wrapper function around your original function, and you are returning these wrapper functions. So now your call me func is not original func, which is basically actually wrappered new versions of your function, where call me func is basically this wrapper function with original call me func, slipping between these two print method. So this is the way to do the decorator, where you define the decorator, can be generic decorator, you pass the function, and whatever function you want to apply decorator, you just pass that method through the decorator, and then you call that functions. So now if you can see here, when you say call me func, you're not actually executing this line, you're actually executing this line, and then calling this func, which is basically this thing, and then this thing. So call me func is like a modified version of or kind of version of wrapper function that you have created through the decorator here, and that is what your call func now. And so this is something you can do. Now this might look like weird, like hey, how I mean I have this call me func, and now I'm like changing the whole, like changing the definition of whole functions. Can I do much more neatly? So to do much more neatly, you can use the annotation. So what you can do is my decorator annotation basically refer to this function called my decorator. So my decorator function name, you just say @my decorator, and you can just pass my decorator here. So this is how without like overwriting your call me func, you are actually applying the wrapper to your call me func. So when you do this, it automatically, when you say my call decorator, Python will automatically take this function, use this decorator to pass that function here, and do all this whatever wrapper does, and return the decorator and kind of like modify the whole thing. So instead of writing this line, you can just say @decorator, and it will do the same thing here. So let me just execute this one, and you can see the same thing here. So as you can see here, I'm calling this I call to, this is the what it prints, and I'm writing my decorator. See here and here, I'm using the same decorator. So decorator is generic. It is a function agnostic. It doesn't have to tie to single function. It's not like this decorator can only apply to one function. You can write decorator, and that can apply to multiple functions. So this is something decorator, very simple. We didn't use any parameter. So what if my function has a parameter? How that will work? So same old thing. You can use something called this positional arguments and keyword arguments with star and double star. So when you have functions which has, when you want to make a function also, when your decorator also want to support parameters, you just pass them. So let's see here. I'm creating this decorator, which is taking functions, and in the parameter, what I'm also passing this arg and keyword. So this function, whatever parameters this function will have, will be automatically passed down to this wrapper. Again, this wrapper can be name anything. It can be my wrapper, it can be inner, it can be whatever. Just remember to return the same here because this is the name of the function. So wrapper doesn't have to be the same name. It can be any name, like keyword, like arg, like keyword, like my decorator. This wrapper can be also any name. Just to throw it out there. And then you call your functions with arg and arg keywords, and then you return the wrapper. So you can see the effect here where I have this method without any parameters. I have this another wrapper, another method with 2 parameters applying the same decorator. But because I'm passing this keyword argument, it's just like passed down. Those keywords will be again passed down with this function. Now let's look at the very useful use case, like why or when this is very useful when you want to use the decorator. When is the very use case? One of the biggest use case that I've seen of using decorator, apart from logging, is authenticating user. Let's say you are using some kind of web applications, and inside the web application, your custom user is trying to, let's say you have some user who is passing some authentication token and try to execute the method. So what you want to do is you want to achieve that every time I execute some method, I first want to evaluate that that particular user is kind of like authorized to execute the method or not. That happens a lot in web applications where anyone can use web app or your web public or your API endpoint to call the method when you are like building your API endpoints and which is open to public, and you only want to give access to people who have authentication to, call those public methods. So you can use something like this where you can define a decorator, and that decorator's job is to authenticate whether the particular user is authorized to execute the method or not. So what you can do here, you can have a method which do what it does, a comma b, and return a comma b, and then you can also pass the token here. So when you define @auth user on this particular thing, so what it comes here as it's a model algorithm agnostic, so foo will be passed here. Here we are using inner and not wrapper, so just to throw there, you can use any keyword here. Same all the keywords, so you can keep intake all the keywords. And now your first keyword is token. So what you can do, you can take out that first argument as a token, and then you can here verify whether the token is this token is valid or not. So if let's say here for our simple logic, if token is not my secret, then I will say that hey, it's unauthorized, and I will just return. So basically I will return the none. So basically I will just invalidate the whole method. And then if things are fine, then I will just like return the function as it is without any changes. And this arg will make sure that the function will be as it is. So it will basically execute the function when you call for inner method. So let's when you apply here, authenticate a comma b, and when you say apply here, so basically this auth user, you can apply to any method, and that method will take off this token and make sure that the user who is using this method is you can like verify that user here in this part. So this is one of the very good use case of decorator. I have seen this one as too much in a lot of the public code base. So let's do this. So here I'm passing something guest password as like some random thing, and 3 and 5, which will pass down to here, and then it will verify with this code and say, and it will just print the whole thing and return none. And if I try to like, let's say print what it is actually, it will say none, because it will print this thing, but it will return none. So basically auth user, the decorator, will return none and not actual function. Now let's look at the second one, bar my secret, which is like correct thing. So it says it does nothing, it just do its job. And if you want to print what it is actually, sorry. This is the result actually. Okay. The idea is when you return, so basically when you are authenticating, you're returning nothing here, but when you are making sure it is the right thing, you're returning the actual function here. So when this happens, it return none, but when this happens, then it actually return the functions, and that is being executed here. This is the end of it. I hope this was useful and you guys were able to execute things and learn from it. Thank you very much for joining us. Again, thanks again, Jeff and his team, and Elise for sponsoring the whole thing, the whole Zoom meeting and setup. Thank you guys for staying a lot longer than I anticipated. I should have said 1.5 hours instead of 1, because that's what it actually took. All these things are being recorded, so you'll be able to see the whole notebook as well as the whole recording that we are doing for today's meetup here. Feel free to join our Slack channel and ask questions there. I'll be happy to answer there, and all the other people on the community who already joined the Slack will answer. All the code base from today and all the previous meetup will be available on GitHub, so you can look up on this GitHub page our repository where we post all our workshop materials, including links to the video, presentation, and notebooks that you can see there. Thank you very much again.
Thank you. Bye-bye.